Welcome everyone. This is another exciting learning lab, and this is one that's really cool. I learned a heck of a lot about Shiny, and as I was putting this one together, I learned a lot about the Zillow API, and I'm going to tell you a story about my wife being a realtor and how she was excited when she saw this app. And just basically, this is a very interesting one. It's going to kickstart our journey into utilizing Shiny with APIs. And I'll talk more about that in a minute. Just to recap, this is going to be a Shiny real estate app. That's going to be the focus on this presentation. It's going to be working with Shiny and the Zillow API.
Mm-hmm.
If this is your first learning lab, this is what the structure looks like. We'll do about 20 minutes of presentation. In fact, I even slimmed down the presentation even more so I can focus on a quick demo and then get us into the code. We'll do about 30 minutes of demos, and that's going to be a code demo where I'm going to be actually walking you down through the Zillow analysis. I'll be actually walking through in the RStudio IDE, showing you the code. And then at the end, I've got 3 pro tips that I'm going to give you, and these are ones that you don't want to miss. They're really critical, things that you're probably not thinking about when you're building Shiny apps, but you should be thinking about.
Mm-hmm.
David, would you mind introducing yourself?
Oh, sure. I'm the owner of Sure Optimize. It's a company we help businesses with digital marketing and analytics strategies to reach more customers online. And I'm here to help Matt out with the learning labs and dive into some data stuff. This is always fun.
And this is, you got that right, David. This is going to be fun. Thank you, David.
Sure.
I'm Matt Dancho. I am the founder of Business Science. I am the lead data science instructor at Business Science University. And my number one goal is very simple. It's to help you accelerate your career by using data science and connecting it to the business to generate real results. I'm talking financial results for your organization. So if you're interested in that, you come to the right place. This will be another great presentation that helps you think outside of the box and how you can use some of these tools that I teach to be able to leverage that in your own businesses. All right, so I mentioned at the beginning that we're kicking off a new series. So last time it was a marketing series and we had a 4-part series to that. This time it's going to be a Shiny API series. So what that means is we're going to be linking up Shiny, the tool that creates business apps, with an API, which is something that you can connect up to be able to get data on demand by making calls to the API. So the first one is right here, Lab 28. It's this real estate app, and we're going to be focusing on the Zillow API. The next one is going to be a Shiny oil and gas app, and we're going to be looking at the Quandle API, which allows us to interface to a bunch of different data sources, a lot in the financial and energy spaces. And then the next one, we'll be looking at a finance app that we're going to make with the TidyQuant API, and that's my own R package. And you'll see how you can actually utilize TidyQuant to be able to pull in financial data. And then the final one is going to be on Google Analytics. So showing you how you can make a Shiny marketing app by connecting to the Google Analytics API. Okay. So if you haven't heard, Learning Labs Pro is an extension of our Learning Labs. So what we do is we record every single one of these presentations, plus we give out a lot of very valuable bonus content that is only available to the Learning Labs Pro members. And it's a big benefit of joining that program. It's a lot of value. As you can see, we've got these series that we've been doing. So the last 4 are on marketing. We had a sequel series and so on. And it's $19 a month. So if you're interested in getting the code, getting the bonuses, then this is the perfect program for you. And you get a new lab every 2 weeks. So it's great for continuous learning. All right, so agenda for today. We're going to kick this off with a Shiny app that I created that links up to the R Zillow API. It looks like this, and we'll talk a little bit about kind of what this app is used for, give you a little bit of background about why I built it, and then also talk a little bit about the key concepts as we go through the application. Then next, we'll talk a little bit about the background. I'll give you a story about how my wife is a realtor, and I came up with this idea with her to build a real estate app. And the goal was to help realtors, help mortgage companies, and also help people like you and me who eventually may end up owning a home. And it's one of the biggest decisions in your life. So um, the next thing we'll do is we'll talk about the machine learning workflow, how we can integrate machine learning into this process, and what tools we'll use. And then we'll spend the bulk of our time on actually showing how to put these tools into use. I do want to say that this app is part of that I'm going to show you next. This is a heck of a bonus. This is a 400 lines of code, full-on shiny web app that implements a lot of cool technologies. One that I'll talk about in a little bit is called CrossTalk, which allows using visualizations to actually be the filters, so you don't need buttons and other things to filter. But anyways, that's going to be the bonus this week, is all of the Learning Labs Pro subscribers are going to get the shiny app. So it's pretty amazing, right? Right, David?
Oh yeah, it is. And then even just so you know, the Learning Labs Pro, you get access to all the previous Learning Labs videos and the code itself, and any ones that come in the future as well.
Exactly. So yeah, last week we gave away a Google Trends Shiny app that actually automates reporting. You just click a button and it sends a report to whoever you want to email it to. This week we've got a really cool Shiny app that looks like Google Maps, but it does a lot of. It was built with Shiny, and it does a lot of machine learning under the hood. So we'll talk about that in a little bit. I'm going to wrap things up with the pro tips and give you a learning guide as well. So, all right, let's kick off this demo. And what I'm going to do now is just pull up my RStudio, and this is the bonus app that the Learning Labs Pro members are going to be getting. As you can see, there's a lot to it. It's about 400 lines of code and 429 lines of code. So it's a heck of an app. Took me about a week to put it together, to be honest. It is a full-on Shiny app, and I had to go through several iterations. So I clicked the Run App button, and now I'm going to expose this in the web browser. And so how this app works is the user, it's very simple. The user just inputs an address, and they click the search button. And behind the scenes, what it does is it pulls up that address and its 20 closest comparable homes. So in the real estate business, comparable homes, this is how most realtors make pricing decisions or help guide their buyers and sellers, the sellers to make pricing decisions, and the buyers to make sure that they're aware, if they could be overpaying. So what they want to do is they want to look at what's called comps. That's just short for comparable homes. And so what this does is you put in an address and it pulls in from Zillow the 20 closest comps, and then it runs a machine learning algorithm that models those comps. And once you have that model, you can use explainable machine learning techniques to come up with this visualization here. And how it works is this is what we call a waterfall chart. And you can see we have an intercept. So you can think of the intercept as kind of like the average price of all the comps. And then for this specific property, the price goes up and down based on these features here. So the biggest features, so this red one is a negative feature because the last sold price of this particular property was $131,000. That drops it by $33,000. And then the tax assessment, the most recent tax assessment was pretty low, so that drops in another $13,800. And then you can see that there's some locational features that help to increase the price. The square footage and the comp score increases the price, and so on. And then the final price for the prediction is $148,000. So what this prediction is modeling this thing called the Zestimate. So Zillow comes up with its own Zestimate, and that's what we're trying to get as close as possible to. And basically what this analysis is it's basically reverse engineering Zillow's estimate process. So this is how you can think of it as this is how Zillow's estimation program is working. It's taking in these features and then it's coming up with a Zestimate that's based on all of the available data and for that property in its comparable homes. So pretty cool, right?
Mm-hmm.
Well, it gets even cooler. So there's also this filtering feature, and this is using what's called, it's using several interactive visualization libraries, but you can see that if I want to identify where this property is located, I just click right here. And you see how that graph updated? Well, it gets even better. The map also updated as well. So this is that property right here. If I go back to that filter, I can see that 2902 is the property that I'm looking at. And what I can do is I can double click and that shows all of the properties. And then I can look for interesting things that are related to other properties that are in this comp group. So we can see that some properties are outliers, like this one here. It's a little bit high price given the finished square footage. And you can see that I can use this scroll bar to scroll across and kind of see what's going on with it. I see that it's got some high square footage and so on. If I look at, say, both of these homes, I can see that, okay, this one here, which is 2650 Cleveland, which is this one right here, seems to have a little bit higher square footage. It's got 6 bedrooms. It's got 4 bedrooms, and so on. Its last sold price was $250,000, and so on. So you can not only use this app as a way to identify different properties, but you can actually filter into these properties very easily. So that's using a process called CrossTalk. We'll talk a lot about that, but in my opinion, it makes this app super user-friendly, and it makes it real easy to utilize.
Hey, Matt, really quick, can you explain what the comp score means on the far right of that table?
Yeah, so the comp score, I think that's something that Zillow puts together. I really actually don't know a whole lot about what that comp score is. I think it's like probably like a range of 0 to 20 or something like that. And if so, actually, let me just search again. And if I do the filter, so the comp score, yeah, you can see here it's 9 for this property, 19, 19, 16. So if I click on these properties, so this one and this one, so these are right here, and this one's 18. Whoops, I didn't want to do that. So let me take a few of these away. So you can see that it's kind of like on this line right here. So they're pretty close to that property that we're investigating. So this is the property we're investigating right here. So that's this one right here. Whoops, sorry. There, so this property right here is that the one that we're investigating, and you see how closely, they're kind of on the same line. Basically, like as it gets higher, what it looks like is that it's more closely related to that property. If it gets lower, like this one right here, then it becomes, I think, less related. So that's what I think it is. I didn't 100% research this comp score, I'll be honest. But I feel like that is kind of what it's doing.
Okay, thanks.
So yeah, let's put in a few different addresses. I'll give you a couple more examples. So I have this home test document, and I'm going to put in this home from State College, which is where I live. I don't live in this particular home. I'm not going to give you guys my address, but I will show you an address that's comparable. So search, and you can see what it's doing is pulling up State College, Pennsylvania. We've got Penn State University here, and I can filter in and find that property right here. So this is the property we're looking at, and we can do some cool things like we can see that, okay, we've got outliers, so we may want to investigate those and see, why these ones are priced in the 600,000s when everything else is 500,000 and below. We can begin to investigate those. And, it's pretty obvious if you're my wife, but for me, who doesn't really know, all of the neighborhoods in State College as well, this is up in a specific area called College Heights, which is very close to Penn State University. So naturally, those homes are going to be higher priced, and so on. And then you can see kind of, so this is still on zoned in on this 404 property. So if I look at this property, 734 Jackson Street. So if I copy this, throw it right in here, and then we can hone in on that one. We can then begin to understand, okay, why is this one priced the way it is? So I'm going to hone in on this one. And if I go to the brain tells me that it was last sold for $610,000. The year built, for whatever reason, seems to be in a good range. And then you can see that there's some other stuff in here as well. But those are the main things. So the last sold price is really what's driving this. Okay. So yeah, that's how the app works. We'll take a look at a few other properties later, but I really wanted to just kind of give you a quick demo and show what you can do with Shiny and connecting the Zillow API. Okay.
Mm-hmm.
All right. So now that you got to see the app, why did I make it? And why did I decide to use the Zillow data and so on? So let me give you a little bit of background. So my wife is a realtor, and what she does is she works with buyers and sellers. So people who are looking to purchase a home, and also people who are trying to sell homes and move maybe into a different home. What she does is she does this whole process where she looks at the comps, and she has to analyze a lot of data, and it actually takes quite a bit of time. I know realtors do have access to a whole suite of tools. It's called MLS, but you can do some of that stuff with Zillow. Now, I don't think you can do quite everything that she has, but a huge part of what she's doing is helping these buyers and sellers help them with the pricing decisions and buying decisions. And then she has to investigate, and data is just a big part of that. So what she wants to be able to do is kind of come through that process very quickly, but effectively. It needs to be really well understood why that house is priced the way it is. So what we can do is we can have an application that can help, because we have this vast amount of data on Zillow. What we can do is we can pull in these features that may or may not have an effect. So things like number of bedrooms, square footage, what neighborhood does it belong to, and so on. And we can use these features to, if we can model it correctly, we can use these features then to explain why that model is predicting the home value that it predicts. So here's an example. So what I've done is created a machine learning model using Parsnip, and then I've used this package called DALEX to create this waterfall chart. And you can see that the home price, the average is 400,000, but the last sold price drops it down. But the year built is a good year. The finished square footage adds 11,000. The tax assessment adds more. And then you can begin to understand, okay, how did that price get to be 419,000? So what this does is it provides an explanation, which is more than just saying, oh, this house is comparable and that house is comparable. Why is it comparable? What are the features that are really driving these pricing decisions? So the big benefit here is that the buyers and sellers, it helps get them in alignment. It helps them understand why the market is accepting a certain price for that particular home that's in that particular neighborhood with all of those features. It also helps mortgage companies, which have to assess and appraise the properties before they give out loans, so they can better appraise properties, and it can make getting loans much more easy for people who should be able to get loans. And it also helps the banks understand if the appraisal is lower than what the the sale value of the home, because that can indicate that the person is paying too much. And banks normally, they don't want to provide a loan for more than what that home value is worth, because if that person goes belly up and can't afford the home and it goes into foreclosure, they're not going to be able to get their value back out of it. So it's a risk mechanism for the mortgage companies. And it also benefits people like you and me, because now you get to access information that can help us get the home of our dreams, right? And that's what we all want. So, it's a very, it's an interesting way to use data and data science to be able to connect up to an API and really provide value to a bunch of different customers of this application.
Mm-hmm.
Okay. So I've talked a lot about the application. I've given you a little bit of story about, why me and my wife were talking one day and decided to put this together. And then now I want to give you kind of the background, what went on behind the scenes from the data scientist perspective. So there's a series of tools that we're going to use today. The main one for the API is going to be Zillow. So what we do is we connect to this Zillow API. You basically create an account that gives you access to Zillow's API. And then you can pull in data, you can wrangle it and visualize it. And then the next step is our app needs to do something. And so we're going to create an analysis. We're going to make a model that approximates the reality of the 20 closest competitors, or not competitors, but comparables, and then explain, once we have a model that fits those all of these houses and can predict the price, then what we can do is we can use this package called DALEX to explain, okay, which features are driving that model. And then at the end, all we do is we bottle it up in a shiny application. So this is basically a container for the analysis, and it allows us to take our analysis into production and put an app around it. Okay. There is one other technology that I didn't have on that last slide. It's called CrossTalk. And we'll also be talking about this technology as it relates to Shiny, because I think this is a really innovative and useful way for people to filter using, instead of like these widgets here, using actual plots and being able to click on things and have shared data that allows us to filter and drill down into our data. It's very, if you're familiar with Tableau has a lot of these similar features, so you can do those features in Shiny as well. All right, time for the demo. I'm going to take a quick drink of water, and then we're going to get into a 30-minute demo, and we'll get going.
All right. So a lot of people are asking, and I think they're going to see it right here in the code, but really wondering, how are we predicting this, the sales price and all this stuff using machine learning?
Mm-hmm.
Just watch the code demo, and I think if you still have questions, put them in the Q&A.
Yeah, I'm going to go through the entire process for prediction and explanation. So you're going to see how, for this particular problem, we're going to do that. The only thing that you're not going to see is the full-blown app, how I built that. So you're going to have to sign up for LL Pro if you want that one. So for my LL Pro members, just so they see what all files we have here. So we're going to start with this O1 real estate analysis.r file. That's this file, and I'm going to go through it, and you can see it's kind of this workflow for modeling and explaining the Zillow API. The next thing is I'm going to do a Shiny CrossTalk demo, and what this is going to do is show you what I was just talking about with that CrossTalk technology, show you how it works. We also have an app.r file, which is the full-blown Shiny app. That's like 430 lines of code. And then we have these home tests .md files, and all this is just it's just a markdown file. So it just gives me a couple of addresses that I was testing out. We've already seen this one, so I'll probably once we get to the actual app, I'll show you how it works with some other ones. And then I think that's pretty much it for the files. That there's a www folder that has the Zillow.png file, and that's just what this app.r file will pull in to give the Zillow logo on it. So other than that, that should be pretty much it. I'm going to start off with the O1 real estate analysis.r file, and we'll begin walking down through this this workflow. The libraries that we're going to use today, this is the only one that I really want to call out because you probably you won't get it from CRAN. It's only available on GitHub. So you'll want to run dev tools install GitHub, this command here. And then once you install it, you'll be able to load this library. It's called Real Est Analytics. And this allows us to get a tidy interface to the Zillow API. That just means it pulls it in what we call tibbles and data frames. It makes it very easy to use. The next thing is config. So you'll see me using this package a lot because I have a configuration file that's located right here, this configuration.yml file, and that's where I store my credentials. The Learning Labs Pro members will not be getting that file because that has my personal credentials, but you can very easily create your own credentials with the API, and I'll walk through that process in a minute. So let's see here. So that's the config file. We're going to be doing a little bit of EDA, so I'm going to load the DataExplorer and Skimr libraries. We're going to be doing a lot of modeling. So we've got recipes, parsnip, and yardstick. That's part of the tidy models. And then the explainable machine learning piece is going to be DALEX and iBreakdown. And then the core libraries are tidyverse, tidyquant, lubridate, and then we have two interactive plotting libraries: Leaflet for the maps, and then Plotly for the just interactive ggplot style visualizations. Okay, so to set your API, what you'll want to do is, it's actually this here. You'll want to go and get it and grab a Zillow API. So this website here has it. I'll just open it up real quick. Okay, and all you'll want to do is you'll want to sign up for this Zillow API. And once you do that, it'll give you this ZWSID. It's literally just a text string of numbers and letter combinations. And basically you want to keep that, because anytime you use the Zillow API to extract information and to pull it into your Shiny app, you'll need to have that parameter set. It's like it's basically your access. Okay, so once you do that, then you'll run this command, which is set Zillow web service ID, your API key. I've stored it in a configuration file, so in this config.yml. So if I run this behind the scenes, it's grabbing that Zillow config, and it's piping it into the set Zillow web service ID. So I'm just going to run this, and now I've got my Zillow web service ID set. Anytime that you use any of the functions in this package up here, Real Est Analytics, basically you're going to need to have that. You're going to need to tell it where your Zillow ID is, and you just do that with this get option, Zillow R-ZWSID. Okay. So the first function here that we're going to focus in on in section 3 is the under the Zillow API basics is what's called a deep search. So Zillow calls it a deep search, and that basically you put in a property address. So this is for a property in Ames, Iowa. And when you run this, I'm just going to run this piece here. It comes back with a usually it's a 1-row data frame, but if the address is matched by more than one property, sometimes it can pull 2 properties, 3 properties, or so on. And typically you just want the first property that returns. So that's why I pipe this into slice 1, and that ensures that I only get 1 property back. So what I do is I save this as a variable called target property, and then we can look what features are in that target property. And you can see you've got, in addition to these features that we've provided it gives us the geocoded Latin longitude. It gives us a region name, a region ID, It gives us some information about those estimates. So the date that the last estimate was updated, the monthly change. So it changed from, you know, plus or minus, the Zestimate low and high level. So it gives you a range, and then it gives you even a rent Zestimate. So how much should a renter pay for that property per month? So this particular property is $1,600 per month. And then the same thing for the rent Zestimated. And then it gives you this ZP ID, and that's important because we'll need that next. So consider that like the ID for the property, the Zillow ID. And then it gives you some cool features like how many bathrooms, how many bedrooms, what's the square footage, when was it last sold, what was the price it was last sold for, what was the square footage, the tax assessment or appraisal value, the tax assessment year, and so on. So total rooms and even the year built. So that's when it's saying it's a deep search result, it's giving you a lot of information that we can actually use basically for a machine learning model. And then it's got this next function. So that was the deep search. It's got the top comparables. So we can give it, we give it that target property ZPID. So if I run this piece here, that's just this value here. So you run that, and when you run it in this get deep comps function, then you can pull in the 25 closest comps. And not every property is going to have 25 comps. Some may only have like 10, some may have 15, and so on. But when you run this, you're able to get all of the comparables. So if I look at this, the first property is the property that we just searched. So that's 209 Wood Street. But then you can see it pulls in other properties here too. So 2325 Storm Street, 3920 Fletcher Boulevard, and so on. And all of these are the same information that we have for that first property that we looked at. It is pulling in for comparable properties. So once we have this, we can do a lot of information with it, but we have to process it first. So the next thing that we're going to do is move into section 4, which is this is the exploratory data analysis part. And so we can see if we run this, we can skim the data, see if we have missing values. So we do have some missing values we'll have to take care of. See what types of data that we have. So we have some character data type, we have some dates, we have some numeric data, and so on. And then what we can do is then start to focus in. So the next function that I'm going to pipe this into is plot bar, which is useful for categorical data. So when I run plot bar, it's going to pull in a kind of like this report here. And I can see that there's some last sold date, some ZPID, which is categorical, tax assessment year, which is only one variable. So that's not going to be very useful. And then if I click over here, you see this is page 2. I just switched over to page 1. The address is categorical, zip code. We've got 2 zips. City, only 1 city. So that's not going to be that useful. State, same thing. Region name might be useful because you can see there's several different regions and IDs, but we should probably only have 1 of these. And then the type, which is either city or neighborhood, and so on. So you get a little more information, again, summary information about our data, and we'll see some things that we need to take care of. And then same thing with the numeric data. We can use this plot histogram function. And we're on page 2 here. We can see lots, square footage, tax assessment, total rooms year built. Those are all numeric features. And then if I click over, it should go to the first page. And we've got a lot more numeric data, like latitude and longitude, and the number of bathrooms, the number of bedrooms, and so on. We'll want to get rid of some of these because when we develop a predictive model, we don't want to include any of these like rent Zestimates, because obviously the Zestimate is going to be very correlated to the rent Zestimate. And same thing, it's going to be very correlated to Zest percentile, Zestimate high, Zestimate low. So we'll want to get rid of some of those features before we do a predictive model. So now that we have a good sense of the data, we're ready to do some pre-processing. So what we're going to do is use this recipes package, which is my favorite pre-processing toolchain. The first thing I'm going to do is I'm going to convert all strings to factors. So that just makes it all the data essentially categorical data. So if it's encoded as a string, it'll make it a categorical feature. So that way we can make it into a dummy variable. The next thing that we're going to do is run step mutate and change the date feature that I'm going to keep in here from a character value to a date value. Then what I'm gonna do is I'm gonna remove any of the features that I don't want to retain in the model. So things like address, state, region ID. Remember, region ID and region name. We only need one of those, and so on. So I'm removing a lot of these features. Anything that contains rent, anything that contains high, low, which this is the Zestile high, Zestimate high, Zestimate low, and Zestimate percentile. So it's going to remove all those. We're going to convert date features to we're gonna build some engineered features out of those. So anything that's a date that's retained, we're gonna create a year, a month, and a decimal date feature out of it. We're gonna remove the date feature because we don't need that anymore in the model. And then we're going to impute everything to remove any NA values. So this is the pre-processing tool chain. I teach this in depth because every data set's different and needs a different set of pre-processing steps. So I teach this mainly in the 201 course. And if you're really interested in learning how to use this, I highly recommend it. So this is the recipe. So now what I want to do is I want to process that data set. And I'm basically applying this Zestimate recipe to the initial raw data for all of the comps. And when I do that, and then if I start looking at it, now I'll see that, okay, all of those features have been converted to basically numeric features or factor features. So that's okay. I can see that there's no missing values. It's imputed everything using k-nearest neighbors. I can verify that with this plot missing function. I see all the features have 0%. I can check out plot bar to see what features, what categorical features were retained. So I've got last year sold date, 2019 and 2015. I can see the region, the months that last sold date were retained, and so on. And then the same thing with the numeric data. I can see which numeric data. I can verify that the estimates were all removed. We can see that there's a lot less features here now, which is a good thing because we don't want those estimates in here to basically for our algorithm to key in on. Okay. All right. So now that it's been pre-processed and now it's a data set that has all the missing values removed and so on, we're ready to do some modeling. So I teach modeling with the ParseNet package. I teach that in the 101 course in depth, all of the different algorithms. We're just going to use XGBoost in this, and we're going to pre-select some parameters that tend to work decently well. And we'll keep the number of trees relatively low. If you take this up too much, it'll end up slowing down your app because we're actually going to train a model every single time that user enters in an address. We're actually going to pull in that data behind the scenes, run a quick model on it, recognize it's only 20 data points or 25 data points, so it's not going to take that long to train. But we don't want to have to take too much time to develop the model. So these are the parameters we're going to use. I'm going to run this, and that creates what's called a model spec. And you can see that this is the specification of that model that we're going to apply. I'm going to set the seed, and then what I'm going to do is I'm going to apply it to the pre-processed data. Or the post-processed data, I should say. So I've got the model spec, I've got a formula. Our Zestimate is our target variable, and we're going to use all the variables that are in this data frame to be able to produce that model. Okay, so it's going to use all of these features in here to model that. All right, so when I run this, lightning fast, we have now a model that has been fit. And we can see that it's a parsnip model object, and it's got an XGB.booster model that's in here. And then what we want to do next is we want to now apply it to the data. So we're going to rerun it on the data, and we're going to then add the data at the initial data back in. And when we do that, we'll follow these steps here using the predict function. And then we get something that looks like this, which has now our prediction here and the Zestimate. Okay, so now we have the ability to compare and see what our accuracy is. So we can pipe it into this MAE function and recognize this is in sample accuracy. So it's not going to be something that's like super, it could be overfitting, it could be underfitting. And if it's overfitting, you're going to get a real low estimate here. Generally speaking, these parameters do fairly well and don't overfit. So, you know, I'm pretty comfortable with it, but by the same token, because we're running an app where we have to run a machine learning model every single time, running fivefold cross validation and really doing parameter tuning probably is going to hurt your user experience. So it's a trade-off that we have to make. So we're going to go with the MAE of the in-sample predictions, and we can see that it's fitting pretty well, so it should give us some good explanations. Okay. Next step, though, before we do the explainable machine learning, what I want to do is I want to show you just how to make some of the visualizations that are used in the app. So the first one is taking just my predictions and sample, which is the output up here. And what I'm going to do is I'm going to add a new column called property description, and I'm going to say this as map tibble. And then what I'm going to do is I'm going to pipe it into Leaflet, add tiles and add markers, and tell it to put the markers on the latitude and the longitude. And that gives us a map that looks like this. So this is going to be like the background for that application. So the Google Maps style of app. The next plot that I need is going to be for the thing that allows us to do our filtering. It's going to be a plotly plot. So same thing, start with my predictions. It's property description, which is similar to this, but it has a slightly different format because this uses HTML in it. And you can see that there's breaks here to get this format. So the Plotly doesn't use that. So I run this, and then I run this, and then now I have an interactive Plotly map that I'll be able to like filter and so on. And that's basically how you do it. You just start making these kind of individual pieces, and then we'll tie it into a Shiny app later. The last visualization that we're going to need for this application is that explainable machine learning piece. And this is really that brain icon, right? So you click on the app, and this is the one that gives you the insights. So this uses a package called DALEX. I did do a learning lab previously on explainable machine learning. I think it was lab 18. I highly recommend you attend that one, and it's available in Learning Labs Pro. It really goes into how to use packages like the IML package, and it also talks a little bit about DALEX and goes into the details behind what some of these algorithms do. I'm going to focus in on the waterfall chart, which is built by this iBreakdown package that integrates with DALEX. So the first thing you need to do is we need to create a make prediction function. And then we need to utilize that make prediction function in here. It goes in this spot right here. So once we build this kind of model agnostic make prediction function, then we supply it to this DALEX explain function along with the model, along with the data, and we have to remove the Zestimate, and then we give the Zestimate to the Y, so our data that's being trained on, and then we've got our Y value, our target, and then the prediction function. And then these are just some additional parameters, colorize false and label waterfall chart. So when I run that, you can see it creates this DALEX object down here, and it gives you a little information about what's been created. It's a new explainer has been created. And then what we can do is use the iBreakdown package to create what's called a breakdown, and this is that waterfall chart. So you just run using this breakdown function. You supply it the explainer. You supply it the observation that you want to explain, which is just the initial observation. And then it comes up with this pred breakdown XGBoost object, which looks something like this. And then we can plot that using the plot function. I'm just going to run this whole line of code here, and it's going to produce over here. Let's see, where is it? Plots. Ah, there it is. Okay, so it produces this plot here. And you can see it's just a static ggplot. It's got the intercept, and then it shows you which features are really driving the price compared to the comparables. Okay. All right, so that is a full Zillow analysis. Pretty cool. We now have kind of shown you all of the components of that Shiny app that go into it. There's one more thing I want to show you, and then we'll finish up with a little bit of an additional demo, look at a few more prices, and we'll talk a little bit about kind of the decisions that went into building the Shiny app. So the first thing I want to show you now is this O2 Shiny CrossTalk demo. That's this file right here. And what this is, so this is just an R Markdown document, and it's using Shiny to run it. And it's the only kind of thing that you're probably not familiar with if you've been following, the things that we've been using, is this package called CrossTalk here. So what CrossTalk does is it allows us to use this concept called shared data, and it allows widgets, what they call HTML widgets, but an HTML widget is like the Leaflet library, the data table, DT library, and the Plotly library. These all create interactive visualizations, and these three libraries are CrossTalk compatible. So that means that you can create shared data using those, or using CrossTalk, and then supply it to each one of those widgets, and they'll actually talk to each other. So it's really cool. So this is just kind of the very similar code to what we've seen already. We're making a ggplot. We're going to use ggplotly here. We're going to make a data table. So we didn't see this, but all this does is it just takes our data, which is going to be this quakes data frame, and it's going to sample 100 of these quakes. It's just a data frame. If I run that, let me see what quakes looks like. What did I forget? I missed this part of it. So you can see it's just a data frame. It's got a lat longitude, a depth, a magnitude, and stations. So we're going to sample 100 of those. And then what we're going to do is we're going to map it, we're going to visualize it, and we're going to show you how to filter. So when I run this, what that markdown is doing behind the scenes is using Shiny. So you can see that it's got this little spinner here. It's actually being served by Shiny right now, which means I can utilize the ability to run a server. So if I just want to say like hone in on these 5, you can see that this data table object updated. You can see that the leaflet map updated. And you can even see that this filter, even though I don't like using these filters because it kind of goes against the purpose of using CrossTalk, but that updates too, even the range. So you can see that the range of magnitude is between 4 and 5.6, and so on. If I do even more, we can see everything updates. So that's the purpose of CrossTalk, and that's why it's so cool, because it allows people to, instead of just instead of using these filters all the time, actually just like click on stuff. So if I want to hone in on just like a certain subset of data, I can just click on it, and then that subset has been updated down here. It's been updated over here. Say I just click on these 3 properties, or these 3 earthquakes. You can see that it highlights. If I click on a 4th one, it's not highlighted this one, and so on. And it's also highlighted the points over here. So it allows us to have this kind of like Tableau-esque, having all of the different plots talk to each other. So that's kind of like the big deal. Once you understand those 2 concepts, then all you need to do is learn Shiny, which is what I teach in my 102 and my 202 courses. And able to build this app.r file. And I'm actually going to give this to all the Learning Lab Pro members. Unfortunately, on the call, I'm not going to be able to go through it because you're not all Learning Lab Pro members. So I will just say this. It's a pretty complex app. So it's something that you really need to know a lot of Bootstrap. You need to know how to do the CrossTalk, which is kind of what I just went over, and the visualization piece as well. So probably the most challenging piece of this app is being able to use different panels and kind of utilize CSS and Bootstrap to be able to style it. So if I run the app, we'll just talk about this for a second. You can see it's kind of got this this screen up here. So let me make this a little bigger. And what I was going for here, so I want to talk about why I built it this way before I kind of move on and show you some more analysis with it. So I kind of modeled it after Google Maps. So like you can see here, you got a search bar here. Like it's very a simple app. Like if you look at Google Maps, there is so much going on behind the scenes, but the user doesn't need to know any of that. It's got maybe one button down here. It's got a few more buttons over here, but generally speaking, that user is going to be doing a search, and then they're going to click on stuff. So if they want to look at all the bars in State College, PA, just that one click is all they had to do, and it shows them, you know, all the data that they need to know. So that's really what we're going after here. And I think most data scientists, they spend too much time trying to fit so much into an app. But really, I think what's a better approach, at least in businesses, is I have this apps.business-science.io. I'm going to start adding more apps in, but this this is what's called an app library. What we can do is we can have this Google Maps style app as just one of the apps that are in our library that people have access to. And then you can filter to different apps, like ones related to stocks. You just submit that and it pulls up those apps, or ones that are related to, we'll say, this is Old Faithful. So just type in old, and it filters your apps for you. So what you want to try and do is really think about that user experience before you just go in and start building a dashboard. And I'm going to show you examples later of in the pro tips where people went the wrong direction and it just turns into a real mess. Okay, so anyways, back. So just understand, I was kind of modeling it after this Google app. So you can see it's got the same style where we've got our inputs here. It's very simple, you know, 2 buttons here, and you've got the information you need. And then it's got something down here if you want to learn, you know, learn how to build shiny apps, go to Business Science, and it's got the information about Zillow here. So the main thing is a map. So that's what the background is. And then the sub-level of analyses are just these drop downs. So you can leverage drop downs to really add that extra complexity to your apps. Okay.
Hey Matt, really quick. Steven asks, how does CrossTalk differ from the Shiny JS taught in the 102 course?
Shiny JS is really just it's more like the Shiny widget, like adding things to have some CSS action, like hiding and showing things. Shiny JS does not allow like anything to talk to each other. Like when I hover over this, see how this it's kind of tough to see, but see how this data table updated. You can't do that with Shiny JS. Same thing, how the leaflet like understood. It's because they're all talking to each other using a shared data source. Okay. All right. I hope that answers the question. Shiny JS is really useful though. I use it a lot for like hiding and showing things.
Okay, thanks.
Okay, and then the home tests. So I want to run up just a few more home tests. We'll take a look at another home here. So what I'm doing here is just searching another home that I wanted to check out back in Pittsburgh, PA, which is, you know, where I used to live. So if I refresh this, you can see that it's now looked up Pittsburgh, PA, Frick Park. I used to ride my mountain bike here all the time, and I'm looking at properties that are, you know, right next door. We can also look over here at Washington, D.C., and you can see how easy it is. All the user has to do is just know the property that they're looking for. And then they can get all the comps that are located next to it. They can search the property and find out, you know, kind of a little bit more about it. Obviously, this is DC, so these prices are a little bit outside of my, you know, price range. But you know, if you're pretty wealthy, then sure, why not buy a couple of these places? So yeah, that's how the app works. Notice that there's no like instruction. There's no like help menu or anything. That's because it's so obvious the way that it works that it's very easy to understand. You know, there's no training involved. And when you make apps like that as a data scientist, that's when it becomes super powerful. So, all right, let's get back. That's the demo. I want to talk about just real quick the pro tips. So the first pro tip here, and this is a app that I pulled off. I saw on the internet somebody was selling it for like $50. You know, on first glance, it's a cool app. You know, it's got the Plotly charts in here, and it's nice and bright. But the problem with this type of app is that you really need a whole lot of training to understand. I mean, it's got 1, 2, 3, 4, 5. Like this is 4, and then it has a drop down 5, 6, 7, and then it's got a help file. It's a dead giveaway. If you have to include a help, you know, a whole section of your app dedicated to help, your app is too complicated. What should happen is you should break these up into sub apps and utilize an approach, something like this, where you have a meta app that calls out, like think of it like the App Store, right? Like an app on your phone, you don't have 5, you know, 7 different functionalities out of it. You have one functionality. It's a calculator, or it's a you know, a stock app or something like that. Like you need, as data scientists that are building apps, you really want to think about user experience, because if it's something's too complex, I have news for you. Your audience, meaning the other people in your organization, are probably not going to use it. So you really want to increase the usage, and you do that by simplifying your app and solving one very specific problem that's important to your audience. Don't try and design it for everybody. Just try and focus on maybe one group that has this problem. So that's my first pro tip. Make your interface as simple as possible. So don't do this where it's got like even this tab. They go to this tab and it's got 20 more buttons. You know, that's too many. So don't do that. You can see conversely, this app, it has 2 buttons and 1 input, and that's it. And that gives you all the information that you need. Let the user have access to the API data so they can kind of type in whatever street address they want, and it's very flexible. And it just provides a much better user experience. And it's also very similar to Google Maps, so they're automatically going to know how to use it, right? The next thing is use the visual filtering that's in CrossTalk. This is a very effective approach. So if we go back here previously, this person had a bunch of different selections and this and that. Rather, utilize this doubles down. So you have a ply here that naturally gives you information, square footage on the x-axis versus prediction on the y-axis. So that person can already see something's going on, and then they can use this as a button. So it's got 2 functionalities. First functionality to show information, the second functionality to be able to filter. So you killed 2 birds with 1 stone. You're giving them information, and you're also allowing them to use that as a filtering mechanism. So what the net effect is it automatically cuts your app in half. You don't have to have an extra filtering button. And then the same thing with the table. It gives them that information. They can scroll across the table, find out, you know, why these comps look like each other or why they differ, and then use the map in the background then. So this is actually a very complicated app, and you can think of it as maybe like 3 of these pieces, but all overlaid on top of each other. So that way that user can kind of get that user experience of complexity and flexibility without the the user interface being overly clunky, right? Okay, and then my third pro tip. So the first one was keep it simple. The second one is use the visual plotting with CrossTalk and being able to filter. The third one is find ways to go beyond reporting. So we're now in 2020 and businesses no longer have use for data science reports. So if you're doing like what I did at the beginning, which is I just ran through a Zillow analysis for one property, and if you put that into a report, think about how many reports you're gonna have to publish for people looking at different, all the different properties that they might be interested in. Rather, give them an application and they can do that reporting for them, and without even creating any paper, without even creating any PDFs, they can just use the app. So this is what businesses want now. They don't want reports anymore. Reports are not scalable. So you cannot scale a report. A report is a one-to-one. And if you email a report, who knows if that person's going to even read your email and read your report. But if you build apps, you can actually track usage. You can scale that to many, many departments, and you can provide the same app and allow them to use that visual filtering and have the inputs to be able to adjust and make it super flexible. So let your audience interact with apps. And what this does is we can then leverage machine learning and explainable ML tools to help with that decision making. So you can see behind the scenes, your analysis is running in the background, but Shiny is just the user interface for that analysis. So this is actually an employee attrition prevention app, and I'm actually working on the course now to be able to teach that. And it's just another course in my growing integrated system of Shiny application courses. So that leads me right into the learning path. So if you really want to learn this stuff, and if you really want to build advanced apps like I just showed you here, number one, join LL Pro, because you're going to be able to get this app and then you can modify it, swap it out, swap out Zillow API for, whatever, API that has geographic data, like your customer API or whatever, your CRM system. You can just swap those out and you can reuse the same type of app. So that's one way. The second way, and even better yet, is actually learn how to build these on your own. And that's what this 4-course R-Track system does. So to learn, this is kind of the learning trajectory that every data scientist goes through. You learn the foundations. So I have a 101 course. And what the 101 course teaches is things like data cleaning and manipulation, visualization. We saw a ton of visualization here, geographic, time series, or not time series, but like a scatter plot, and then even tables. So being able to wrangle data is very important, and visualize it is equally important. It teaches data science algorithms. So the parsnip package that we use for XGBoost, it teaches all of the main algorithms. It teaches for iteration, and then even our markdown for business reporting. So once you get those foundations set, then you're ready to move on to some more advanced things like H2O, which is the package, the machine learning algorithm that I use for this advanced application. It teaches Lime. Lime is the plot that's being generated here. It's a very fast plot to be generated very quickly. And it teaches an end-to-end business consulting framework and project that you follow for 10 weeks, actually solving an employee attrition $15 million problem for an organization. And then once you get the analytics taken care of, so you've got data science down, you got advanced machine learning, then you're ready to start building the apps. You learn Shiny, HTML, and CSS, first building kind of web dashboards, which is where people normally start out, and they're very useful to businesses. And then you go into the more advanced stuff by building, full end-to-end, full stack web apps like this one that can manage multiple users. You learn Bootstrap, MongoDB, Docker, Git, and AWS, so you can actually productionize your web apps too. So that's a whole different ballgame in itself. I teach how to do that in my newest course. So that's the system in a nutshell. Just to recap, the 101 course, you got a ton of content in there. It's 7 weeks. You're doing 8 hours of video lessons just on machine learning. I have frameworks. I have, all sorts of information, challenges. You're building 2 project reports in more Markdown, and you're really learning the foundations. Plus a whole lot of data manipulation, time series, text, categorical, and so on. The 201 course, which is really super powerful. You're going to solve a $15 million business consulting problem, and it goes through an end-to-end project where you follow this framework every step of the way. You use advanced tools like H2O AutoML, Explainable machine learning, Lime, and you learn them in depth while you watch me code step by step. And then the last 2 courses, you're going to make 2 different apps here, a sales dashboard and a product price prediction and recommendation app. So that's very useful. You're going to apply machine learning to some dashboards. And then in my newest course, which I'm super pumped about, is the full stack web app, where it actually integrates the Tidyquant API, a Mongo database backend for your user data, and it can actually track multiple users that are using your apps and have completely different configurations for every single user. Talk about giving them a custom experience, when they can actually select their own stocks that they want to look at, and it saves it for them, and then they can, open it back up and it picks up right where it left off. And then also deployment. So Amazon EC2, Shiny Server, you're going to learn Docker, Git, Bootstrap, MongoDB. Awesome course. The whole system, I offer it as a package. It's called the 4-course R track, and you can see all 4 courses right here. And we have a special promotional discount. And David, if you want to give them the promotional code, 15% off. I would love to have you in these courses. The promotional code is learninglabs, all one word, and you'll get 15% off. So I'm excited about it, as you can tell, and I really want to have you in the courses and help you advance and accelerate your career by building web apps and doing data science.
Awesome. So yeah, I put the link in the chat for the 4-course bundle. Take a look at the course descriptions. Also, if you scroll up just a little bit, someone asked about Learning Labs. There's a Learning Lab Pro link in there for anyone who's interested in that. And again, if you have any questions on specifics, like which course should you take, just quickly put that in the Q&A and we can answer that as well. I think we have pretty much all the questions answered. It's been a lot of activity in the chat, so it's been a lot of fun interacting with everyone.
Good.
Are there any more questions before we head out, guys? Just give it a few seconds here.
Okay.
Is it lifetime access? Yes, it is. And you don't have to try to finish the course in a specific amount of time. It's all self-paced. And one other thing we tend to forget to mention, anyone who signs up for a course, you get access to a Slack group for all the data scientists who have been in the taken the courses are in this Slack group.
Right. And you get access to me too.
That's right.
So it's a really good way to prevent that point that a lot of data scientists, especially early on, and when they end up giving up, is they run into like simple things like error. You run into an error and you just can't get beyond it. You don't know how to fix it. You got a Slack channel.
Yeah.
You can ask me, and you also have 700 other students that are in there, and it's growing every day. So we have even more people, and it's a great community because we all want each other to succeed, and you pay it forward. So like initially when you're starting out, you have a lot of questions, but as you gain knowledge, those people that have gotten their questions answered end up giving it back. So it's a continuous cycle of really helping and cultivating a great learning environment. So
yep, indeed. And that actually is a good point. There's a good over 700, I think now, data scientists part of the community. who've taken courses and are currently in the courses. So
We're up to actually up to 900, and I just looked this morning, 960 students.
okay, so
So
yeah,
we're like 40 away, and I think I'm crossing my fingers. I want February to be the month that we hit 40, so or hit 1,000. So
yeah, exactly,
yep.
exactly. Let's see. Yeah, people are asking also, are we going to share this recording? Most learning labs, almost all of the prior learning labs, the video and the code have been a part of Learning Labs Pro. For this particular one, we are sharing the video, but all the code, the Shiny app, everything you've seen in the code demo is only available to Learning Labs Pro, and that's just what that program is set up for.
Yeah, if you really want access to any of the content that you saw here and any of the content and any of the other learning labs, which we're now done, this is the 28th one. Just sign up for LL Pro. That's the easiest. It's $19 a month. I mean, I don't think you can beat that.
Yeah,
So you get a Shiny app that took me like a week and a half to build for $19. So
yeah,
I think it's worth it.
yeah. I think so too. I mean, it's just, and again, it's like you get access to, and there is a Learning Labs Slack group as well. So you get access to everyone that's part of Learning Labs, and you get access to the code, and you can use these for. You can retrofit the apps to make it your own for your own projects. You can use it for a portfolio of work. We do recommend that if you want to use it for a portfolio, you really understand what's going on in the app. You don't want to,
Yeah,
apply for a job and they ask you about details and you don't understand. But
yeah,
there's a lot of value you can
yeah.
get from just the Learning Labs.
And just to add to that, David, the 201 course, you actually build this. So talk about a portfolio. This is a portfolio right here where you can add all of your apps. They're all this is actually hosted on AWS. I actually teach the students how to build the same thing, and they end up building it progressively through the course. And now they have a portfolio that they can show prospective employers.
Mm-hmm.
Um, it's really great because employers can actually see this and they're like, oh, I could use that in my job or at my company. This guy's hired or this person's hired. So
Yeah, exactly.
yeah.
Cool. I think that might be all. Well, we really appreciate everybody spending the time with us again. Thanks for joining. In another 2 weeks, we'll do it again.
Yeah, thanks everyone. Great having you on here, and keep in touch because we got a lot more coming. Remember, four more Shiny plus API tutorials. So that's going to be the next three coming up. All right, I'll see
Yeah.
you.
Take care, guys. We'll see you soon.